Have you ever wondered why the ocean doesn't just sit still? What mysterious forces keep it in constant motion? The answer lies in the unseen power of ocean currents, continuous and directed movements of seawater that play a crucial role in shaping our world. There are two types of currents: surface currents, primarily driven by winds, and deep ocean currents caused by differences in water density. We are about to embark on a journey beneath the waves, exploring the invisible highways that shape our world. Imagine the ocean surface as a giant conveyor belt, driven by the power of the wind. The wind belts, like the trade winds and westerlies, are the main architects of this movement, setting in motion the surface currents. They generally follow the gust and drift patterns of these winds. A perfect illustration of this is the Gulf Stream, which flows from the Gulf of Mexico towards the North Atlantic, riding the prevailing winds. But these currents are not just aimlessly wandering. They play a crucial role in climate regulation by redistributing heat around the globe. For instance, the North Atlantic Drift, a branch of the Gulf Stream, carries warm waters to Western Europe, decidedly moderating the climate there. So, surface currents, under the command of the winds, are like the ocean's climate control system, ensuring heat from the sun is spread evenly across our planet. The winds may steer the surface, but what about the depths below? What powers the currents in the deep ocean? Deep beneath the waves, a different kind of current flows, one driven by differences in temperature and salinity. These deep ocean currents, unlike their surface counterparts, result from the thermohaline circulation, a process where water density changes due to variations in heat and salt content. Picture the Antarctic bottom water, a cold, dense current that embarks on a slow northward journey along the ocean floor. But don't let their languid pace fool you. These currents play a critical role in global heat distribution, acting like a vast underwater conveyor belt that transports warmth from the equator to the poles. And it's not just about heat. They also move nutrients around, essential for supporting marine life in the deep ocean. So, while these currents might be out of sight, their impact is certainly not out of mind. From the surface to the very depths, ocean currents are a powerful force. But what does that mean for us? These unseen highways of the ocean don't just move water around, they have profound effects on our world. Let's dive into the major impacts of ocean currents. For starters, they're like nature's thermostat, regulating our global climate by redistributing heat. The Gulf Stream, for instance, is a warm current originating in the Gulf of Mexico. As it flows towards the North Atlantic, it carries with it tropical warmth, influencing the weather and keeping the climates of Western Europe milder than they would be otherwise. But the current's impact doesn't stop at the weather. They're also the invisible guides of seafaring vessels. Major currents have been influencing navigation and ship routes since the dawn of sailing. Ships can harness these currents to travel more swiftly and efficiently, while also needing to navigate around them to avoid being carried off course. And let's not forget the marine ecosystems. Ocean currents play a crucial role in influencing nutrient distribution, thereby affecting marine life and fisheries. The California Current, a cold current flowing along the western coast of North America, is a prime example. This nutrient-rich current supports a diverse ecosystem, from microscopic plankton to giant whales. So you see, ocean currents are not just about moving water, they shape climates, guide ships, sustain marine life, and so much more. So next time you look out at the ocean, remember its currents, the unseen power shaping our world. Ocean currents, the invisible highways of the sea, play a vital role in our world. These vast, swirling pathways of water, whether on the surface driven by the winds or deep below influenced by temperature and salinity, are truly the lifeblood of our oceans. Surface currents such as the Gulf Stream and the Kuroshio Current are like the weather vane of the sea, following the prevailing wind patterns and in turn influencing our climate by redistributing heat. They are the silent architects of regional weather patterns and ecosystems. Deep ocean currents, on the other hand, like the Antarctic bottom water, creep slowly along the ocean floor, regulating global heat distribution and nutrient movement, integral to the ocean's conveyor belt circulation. From regulating our climate to influencing navigation routes and supporting marine life, the importance of these oceanic currents cannot be overstated. The more we understand these powerful currents, the better we can navigate our future on this blue planet.